Hello, and welcome to a little video where we're going to practice some linear combination for systems of equations. However, this time, our systems will not have opposites right away. Okay, I will walk you through how I think about this. I also have a nice tool that I will be handing out to you guys to have on the side to kind of walk you through this process as well. Okay, so when I look at a system, the very first thing I look for are opposite symbols, meaning I don't really care what coefficient is attached to the letter. So like if I'm looking at the x's, I don't care what's in front of it. I just care to see is one of them positive and one of them negative. When I take a look at this system, unfortunately, all of the variables have negatives. So I don't have opposites like that. So the second thing I look for is, do I have anything that's exactly the same? Because that's another way to make a system, solving a system easier. Now, number one, we happen to have two negative y's, negative 9y's. Well, we can make them opposite. My hint is we do this through multiplication. What can we multiply negative 9 by to get positive 9? Let's think about it. You can multiply negative 9 by negative 1. So if I do negative 9 times negative 1, we get positive 9. So let's make one of those positive. In order to do that, in order to multiply one of the negative 9y's by negative 1, I have to multiply the whole equation. I like to keep it uniform. When I make something negative, I always make the top equation negative. So I'm going to put parentheses about around both sides of the equation, and I'm going to write that I'm multiplying by negative 1. Okay, we're going to distribute. Negative 1 times negative 2x is positive 2x. Negative 1 times negative 9y is positive 9y. Perfect. We need that. On the other side of the equal sign, negative 25 times negative 1 is positive 25. I don't want to change the bottom one because if I keep the bottom exactly the same, we have a negative 9y. So everything else stays the same. I don't want to change it. Now our y's are opposite. So that means we can go ahead and start adding them. Let's do it. The rest of the process is exactly the same, step by step, from what we've been doing last week. So from now on, nothing new. Let's begin by adding everything. 2x plus negative 4x is a negative 2x. 9y plus negative 9y cancel. 25 plus negative 23 is positive 2. And what do we do for our last step? We divide by negative 2. We divide both sides by negative 2 because negative 2 divided by negative 2 is positive 1. X equals negative 1. Fantastic. We do the same thing as last week to find y. We pick whichever equation we want, first or second. Just make sure it's one of the originals. What do I feel like using? I feel like using the second one. I'm going to be letting every class decide how they want to do it. So my notes might be different in every class, but yeah, since I'm doing the video, I get to decide. Anyways, I'm going to rewrite the second equation. And I'm going to substitute negative 1 in for x. Now I'm only dealing with one variable, with y. Let's find out what it is. Negative 4 times negative 1 is positive 4. Minus 9y equals negative 23. Next, let's subtract 4 from both sides. Since we had a positive 4, we undo it with a negative. 4 minus 4 is 0. So we have a negative 9y equals negative 27. I got negative 27 by doing negative 23 minus 4. So just remember, we're not doing minus negative 4. That's a common mistake I see a lot of folks doing. We're doing the exact operation between them. If it helps, you can think of it as addition. Whoa. I don't know if anything went crazy on your screen. It did on mine. But anyways, if you think of it always as adding, it still works. Anyways, last step, what should we do? We're going to divide both sides by -9, because -9 divided by -9 is 1, and that's exactly what we want. We want 1y. -27 divided by -9 is +3. And there's our answer, -1, 3. Fantastic. Let's try another one. So let's begin with how I was beginning number 1. And I was looking to see if I have positives and negatives for x's or y's. It looks like in this problem, both x's and y's have one positive, one negative. The first equation, or the x's have a -4 and a invisible +1, and then the y's have a +9 and a +3. It does not matter which variable we get rid of first. So, again, I'm going to let each class decide what they'd like. Let's get rid of the y's, just because I'm choosing it this way. All right. I'm going to get rid of the y's. Now, this is how I'm going to do it. Since I already have one positive, one negative, all I need to do is get the numbers to match up. Now, there is a shorter way of doing this, but I'm going to show you the foolproof way as well. I'm going to show you that first. The foolproof way is we multiply the top equation by the number on the bottom and the bottom equation by the number on top. This is what I mean. I'm going to multiply the top equation by the 3 that's in front of y on the bottom, and the bottom equation by 9 that's in front of y on the top equation. I'm going to pause that for a second. Do you see how I did that? I took this 9, multiplied it on the bottom. I took this 3, multiplied it on the top. We would have done the same if it was x's, -4 and 1. Now, what's the shortcut? Well, the shortcut is recognizing that I can make 3 into 9. The shortcut would be just multiplying the first equation by +1 to keep everything the same, so essentially we're not changing it, and then multiplying the bottom equation just by 3, because we can turn a 3 into a 9. But if you're not sure what number we can turn into the other, you can always use this foolproof method. So let's do it. We're going to multiply the whole top equation by 3. 3 times -4x is -12x. 3 times +9y is +27y. And 3 times 9 is 27. On the bottom, let's distribute the 9. 9 times 1 is 9, so we got 9x. 9 times -3 is -27y. And 9 times -6 is -54. So see what I mean? If we just flip those two numbers and multiply, they'll both turn into 27. So it'll always work out this way. If you're not great at your multiplication table, having them memorized and having all your multiples memorized, then this will always work, as long as we create opposites. Your numbers might end up bigger than people who can tell about the least common multiple and that could recognize that you could just turn the bottom equation into a 9y, but it's okay if you don't, because this way still works. All right, let's add. -12x plus, well, hold on, plus 9x is a -3x. 27 plus -27 is 0. They cancel out. Beautiful. And that equals 27 plus -54. I didn't write in my pluses. Let's do that. Is I'm just double checking my math. I'm pretty sure it's negative 27. It is. It's negative 27. We have one last step to do, and that is to divide both sides by negative 3. And we have that x equals positive 9. Fantastic. All we have to do now is plug x into either the top or bottom equation and find out what y is. I feel like plugging it into the top equation. Let's do it. Negative 4x plus 9y equals 9. Okay, we know x. We found out that it was 9. So we're going to substitute that in. All right. Negative 4 times 9 is negative 36, and everything else stays the same. Next, let's add 36 to both sides to undo the negative 36. Negative 36 plus 36 is 0, so we're left with 9y equals 45. And we finish by dividing both sides by 9. We get that y equals 5. Let's write down our answer. 9, 5. Remember to always put it in order, x, y. Alrighty, let's check out number 3. Alright, first let's see, do we have one positive, one negative? No. Everything is positive, the x's and the y's. That's fine. Like I mentioned in number 1, if I'm going to make something negative, I'm going to make the top equation negative, and I'm going to stick to that rule. I'm going to follow the same idea as number 2. I'm going to flip the two numbers. Since we canceled out the y's first in number 2, let's cancel out the x's first in number 3. Now, this is the foolproof way. I actually think that this one only has a shortcut for the y's. But if we're picking the x's, this is the only way to do it. What we're going to do is we're going to multiply the top equation by negative 3, and we're doing this because we need one negative, and we're going to multiply the bottom equation by positive 5. So I flipped the numbers, and then I made the top one negative, right? So if the signs are all the same, we need to make the top one negative. All right, let's distribute. Negative 3 times positive 5x is going to give us negative 15x. Negative 3 times positive 4y is negative 12y. And negative 3 times negative 14 is positive 42. Let's take a look at the bottom equation. All right, so now our x on top is a negative. Perfect, and it's negative 15. On the bottom, 5 times 3x is positive 15x. Good, we've got opposites. Positive 5 times 6y is positive 30y. And on the right side, 6 times 5 is 30. Fantastic. Let's add it all up together. Negative 15x plus 15x is 0. They cancel. Perfect. That's what we wanted to happen. Right, the rest is the same as last week. Let's keep going. Negative 12 plus 30y is going to be, whoops, I'm just double checking my math today. 18y, positive 18y. It's a Sunday, 42 plus 30 on the right side gives us 72. Let's finish by dividing both sides by 18. We're doing that because 18 divided by 18 is 1, and we want 1y. That's our goal. We want y by itself. 72 divided by 18 is 4. Y equals 4. Let's find x. We can find x by plugging it into any of the equations we want. What did we do? Did we do the first one in number 2? Okay, so let's do the second equation in number 3. Because it really doesn't matter. I'm just going back and forth. So we got 3x plus 6y equals 6. We know what y is, so we get to substitute that in. Let's do it. Y is 4. Everything else stays the same. 6 times 4 is 24. So I'm going to write that instead of 6 times 4. And I'm just bringing everything else down because it stays the same. Next, let's undo the plus 24 by subtracting 24 from both sides. 24 minus 24 is 0, so they cancel. We're left with 3x on the left. On the right side, 6 minus 24 is negative 18. And we're going to finish by dividing both sides by 3, because 3 divided by 3 is 1, and that's exactly what we want. X equals negative 6. Perfect. Let's write down our answer as a coordinate. Negative 6, comma 4, because it's always x, comma y. Perfect. I think we've got one more to solve, and then we're going to do some English writing. Okay, in number 4, take a look. Do you see any of the variables that has one positive, one negative? The y's. Perfect. Now that I see one has a positive, one has a negative, I don't need to multiply anything by negatives. The symbols are opposite. So all I have to do is multiply the top equation by the number in front of the bottom, so 7. And I'm going to multiply the bottom equation by 2, because that's in front of the y on top. Again, I'm keeping 7 and 2 positive, unlike the other one, because in number 4, I already have a minus and a plus for the y's. In number 3, I did not. Everything was positive, so we needed to make a negative. Oh, let's scroll down. All right, let's go ahead and distribute. We're going to distribute 7 to the top and 2 to the bottom. 7 times negative 4x is a negative 28x. 7 times negative 2y is a negative 14y. Great, okay, we have a negative 14y. 7 times 14 is 98. Yes, it is. Let's do the bottom. 2 times negative 10x is negative 20x. 2 times positive 7y is positive 14y, and voila, we have made opposites. Negative 25 times positive 2 is negative 50. All right, let's add. Negative 28 plus negative 20x is negative 40x. The negative 14s cancel, or the 14s cancel. And then 98 plus negative 50 is just 48. I don't know why I wrote 40 there. There we go. Last step, let's divide both sides by negative 48. Negative 48 divided by negative 48 is 1, which is why we did that. X equals negative 1. And now let's plug it back in to find out what y is. I feel like using the second equation, so let's do that. Alright, so x is negative 1, so I'm going to write negative 10, substitute negative 1 in for x, and everything else stays the same. Negative 10 times negative 1 is positive 10, and everything else stays the same. I'm going to subtract 10 from both sides to undo the positive 10. So I'm left with 7y equals negative 35. And we get to finish by dividing both sides by 7, because 7 divided by 7 is 1. And then y equals negative 5. So our final answer is negative 1, negative 5. Beautiful. Let's take a look at number 5, which is explaining when each method is best for finding a solution of systems. Now, in my opinion, graphing is best when both equations are, graphing is best when both equations are y equals. Then we have our slope and we have our y-intercept. It's easy to graph and see what the solution is. Substitution is good when one of the equations is x equals or y equals. Linear combination is best when both x and y are on the same side of the equation on both equations. And what I mean by that, I know it's a lot of words, is like the ones we've been dealing with. X and y are on the same side in both equations, right? They're both on the left. They're both on the left. Okay. If you have any questions, please make sure to ask myself or whoever it is that's helping you out in math. Otherwise, have a wonderful rest of whatever day it is for you. Bye!